Right. Okay, so today's leading on from what genetic cross is, and we're now talking about inherited genetic diseases. Now, you need to be aware that certain genetic disorders, where there's been a problem with the chromosomes, can be inherited, or that disease can be passed on, okay? And you need to be able to explain how and why, all right? And there's two main types I need to talk to you about, all right? I want to start with the first one, which is cystic fibrosis. Now, you need to know a little bit about what cystic fibrosis is. Not a lot, but a little bit. So, cystic fibrosis is when cystic... Have you stopped it?
No.
No. It's just right, sorry for us. Cystic fibrosis is when there is problems with the channels in the membranes, right? But what that really means is that you get thick, sticky mucus, and that thick, sticky mucus gets around things like the lungs and the pancreas and prevents movement, all right? So it's hard for a person to breathe and they can't release the enzymes to digest. Do you get where I'm coming from? So thick, sticky mucus, which causes problems with, I'm going to put the word secretions, because that's what causes the problems with the lungs and the pancreas and the enzymes, all right? So that's cystic fibrosis. Thick, sticky mucus, problems with secretions. Now the key is, cystic fibrosis is caused by a recessive allele. Don't let anyone comment on my spelling. We're rushing. So, this means, and this is an important point I need to get across, because it's a recessive allele, you can be a carrier. And it's a word I need you to understand. Anyone know what carrier means? In terms of genetics?
A person who has it.
They have it, but
Someone in your family.
I like that, it doesn't show itself. They don't actually suffer from the disease. Alright? It's that bit about genotype, phenotype again. Yeah? They've got it in their genes, but they don't have it showing. They don't have the disease. Right. So I want to show you an example. Let's do a genetic cross. You will often in your exam be asked a classic question. Right? If two parents are both carriers of the cystic fibrosis allele, what are the chances of their offspring having the disease? It's the classic question, all right? So, you could do this quite easily, I hope. First of all, I would go for the Punnett square. Would you agree? On the top, we'd put the potential alleles from one parent. Big C, little c. Don't forget, little c is the cystic fibrosis allele. Yeah? Okay. And the second parents, we'd put on the other side. You've got to be careful with your C's and how you write them, because C is a very difficult thing. You can get confused quite easy between capital and small. Okay? Right. So then we put our combinations of alleles together. This individual would contain the alleles big C, big C. This individual would contain the alleles big C, little c. Little c, big C, but do I draw it like that? No. And finally, little c, little c. Now, we've got the genotypes, what's in the genes. I want to talk about the phenotypes. We're going to say, are they normal? And that's how it's expressed, as normal, carrier, or disease. What's the phenotype of this individual? Normal, which means they don't have the disease. Carrier, or having the disease. Normal. This individual.
Carrier.
Good. Excellent. This individual.
Carrier.
Carrier. and sufferer or disease or CF sufferer. And I like that as a, I think I prefer sufferer. Now that's great, and you'll be getting 3 marks out of 5 if you do that. But there's a bit more to go. You have to finish it with a very important bit when you're answering this. The question will be, what are the chances? Or what is the probability? Therefore you have to finish with that. And you will circle, and I want you to set it out like this in the exam. And you will say there is either a 25% chance of them having an offspring with cystic fibrosis, or a 3-to-1 ratio. And that's the classic, all right? Very much the classic. Okay. There's one more. And because it's exactly the opposite, I have to talk about it. There are other genetic diseases. I can give you examples of 2. But I think I'll just stick to 1. The main one you'll get asked about is a disease called, oh, that's definitely not spelled right, Huntingtons. Now Huntingtons causes all sorts of damage to the nervous system, but what you really need to be aware of is that the Huntington's allele is a dominant allele. Alright? And therefore, it's a different problem again. And if we were to do a genetic cross, I just need you to be aware that is a classic question. Big H stands for? Big H stands for sufferer of Huntington's, because it's a dominant gene. Does this individual have Huntington's? The answer is yes. Because they possess one of the dominant alleles, and therefore, because Huntington's is dominant, they will show the disease. Can you carry Huntington's? Can you have it in your genes without it showing? No. No, and that's what we're really trying to get across here. There are no carriers. And if we're to do the genetic cross, this will be the same question again. What are the chances of these 2 parents producing offspring with Huntington's? And we put the combinations of gametes together to come up with You're not finished though. Why aren't you finished, Dylan?
Need to work probability.
You need to state probability. Excellent. And what would you say here? There is a 50% probability. Excellent. Stop that for a minute. Right. Now,